Here we'll begin with what is a muscle twitch. So this is when a muscle quickly contracts and relaxes. And this is typically due to a single electrical shock of certain types of voltage or due to one action potential that's firing. Okay. All right. So let's look at this figure up here. And here, this is denoting what is a twitch, okay? So this yellow line is representing the electrical activity. So here we have the stimulus, and then momentarily, then we have this muscle twitch, okay? So here we have a peak, and then it comes back down. So denoting one single event, okay? So the time where we have the stimulus to where we actually see the muscle twitch, this is called the latent period. And so this is where we have the excitation contraction coupling. That's the delay or lag time of the actin and myosin cross bridging, okay, of that cycle. What we also have with a twitch is called a graded contraction, where we'll have a stronger contraction due to recruitment of more fibers until all the fibers are contracting. So this will occur when we have an increase in the voltage that's going to increase the strength of this twitch. So with this though, there will be some type of maximum when we hit all of the motor fibers that are being innervated. So then with twitch, what we can get then is something called summation. And so this is this graph down here that's denoting that. So this occurs when you have a second shock applied immediately after the first. So here again, this yellow is denoting here's the electrical activity of one, and then here's the second event. And so what we see with the muscle then is that we have this increase in response, and so this is called like a piggyback effect, where the recruitment is going to be greater than just with a single event of a muscle twitch. So another type of activity that can occur with our skeletal muscles is called tetanus. And so there's two different types of tetanus. Let's start with incomplete tetanus, and this is denoted by this image right here. Okay, and so this is where we increase the frequency of the electrical shocks, and this is going to decrease then the amount of relaxation time between twitches. So in essence, this is kind of like summation that's continuously occurring. Okay, and so here we have incomplete summation, where we have here on the bottom, this is denoting the electrical activity. So here we have 5 events or 5 shocks, and then the second one is showing 10 shocks, okay? And so here you can see it's increasing in muscle tension. And with this incomplete one, with this 5 shocks per second, you see it's kind of jagged and kind of asynchronous. Whereas when you increase the amount, so up to 10 shocks per second, we're starting to get this smooth contraction of that muscle. The second type of tetanus now is complete tetanus, and so this is where we have a smooth sustained contraction, and this is due to a certain frequency where there is no relaxation that occurs. So here now we're going up to 60 shocks per second, and so here you have this smooth type of muscular contraction, okay? And so over time though, what happens is that our muscles can't sustain this activity for a long duration, and so we start to get muscle fatigue, where our muscle tension or contraction starts to decrease until it just gives out and relaxes, okay? So with this complete tetanus too, we also have some motor units that are going to start to twitch when others are starting to relax, and so this will produce this continuous contraction of the whole muscle for a certain duration, and then the recruitment then is going to make the contractions of that muscle stronger. So we see this, like this strong recruitment, say for instance within our hamstrings or our quadriceps. So now let's look into the different types of movement that can occur with contraction of muscle fibers. And so we'll look at isotonic and isometric, but let's begin with isotonic. So isotonic contractions will maintain constant tension in the muscle as the muscle changes the length. okay? So here the iso meaning same, tonic refers to tension, so same tension or constant tension, okay? So there's two different types of isotonic contraction. We have concentric and eccentric. So with a concentric contraction, this is a type of muscle contraction where the muscle fiber will shorten while generating force. And so this is now overcoming resistance. So here, if you look at this top figure, this is an example, so like doing a bicep curl, okay? So when you're lifting a heavy weight, the concentric contraction of the biceps causes the arm to bend at the elbow. And so this is going to lift the weight towards the shoulder. In terms of the cross-bridge cycle, this will still occur. You have shortening of the sarcomere, the muscle fiber, and the muscle to produce that movement. Eccentric contraction will result in the elongation or lengthening of a muscle while the muscle is still generating force. So in essence, the resistance is greater than the force generated. So eccentric contractions can both be voluntary and involuntary. So let's look at an example of a voluntary eccentric contraction. And so this is where you would have controlled lowering of the heavy weight. So in this example here, you are bringing that weight back down, but you are controlling that movement. However, involuntary would be like if this weight would be too heavy, and so this would cause the muscle to lower it and then to basically fall at a faster speed. So in terms of a cross-bridge cycle, this is still occurring even though the sarcomere, muscle fiber, and the muscle are all lengthening. Okay, but these are just being controlled in the extension of the muscle. So instead of shortening of the muscle and the sarcomeres, we're having now lengthening back, okay? So the second type is isometric contraction. So this is where force is generated without changing the length of the muscle. So iso for same, metric for length. Okay, so same length of the muscle. And so this is common in the muscles of the hand and the forearm that are usually responsible for gripping objects. So this is isometric contractions are also frequently used to help maintain posture, and this also can be voluntary. So for me, for example, I'm constantly holding my baby, and so that is under isometric contraction conditions because the length of the muscle is not changing, but it is generating force to help hold my baby so he doesn't fall down. When we talk about contraction, there is this trade-off for velocity of shortening versus the force, okay? So this is considered the force velocity curve, what we're seeing here. All right, so let's begin by looking at here on the y-axis, we have the velocity of shortening, and then here on the x-axis, we have the force or the tension, okay? So when we have a minimal to zero force, we have a maximum amount of velocity for shortening for those sarcomeres and for the muscles, okay? However, if we increase the force, what's going to happen is this trade-off where the velocity is going to decrease, okay? And so here at this point, what this is representing is that contraction at its maximum force, this is considered to be isometric because we're not able to lengthen that muscle anymore, okay? So again, the greater the force, the slower the contraction. And the opposite is true. So the lesser the force, then the greater the contraction. So again, this is this trade-off that we have to have for our muscles when we talk about contraction. So muscle strength is going to be determined by 4 different factors. The first being the number of fibers that are recruited to contract. The second being the frequency of stimulation from the motor neuron. Third, the thickness of each muscle fiber. The thicker a muscle fiber, the stronger it is. And then fourth, the initial length of the fibers at rest. So when we talk about the sarcomere though, and how this relates to muscle strength, let's look at the difference in composure of it, okay? So tension is going to be maximum when the sarcomere are at normal resting length. So this one represents the max, okay? Because here we're looking at normal rest. Then an increase in length will decrease the muscle tension. And so this is when we have lengthening of the muscle, okay? So here we're going to have, I'll have an arrow saying decreasing, and so there's going to be less interactions between actin and myosin, okay? And so at some point, this means that there is no tension that can be generated. All right, so I'm going to change gears and look at the graph up here. So that is going to be an example of when we are overstretched. Here, this area, this middle part, is going to represent the maximum. So this is when a muscle is at rest. And then the third situation is when we have a decrease in length, we'll also have a decrease in tension because the fibers get shorter and thicker. So we have maximum overlap between actin and myosin, and so this actually is going to increase fluid pressure within the tissue of the muscle, and also this actually has a decrease in distance between actin and myosin. So this maximum overlap is not a good thing. So this is when you are, like say, doing a bicep curl, so you are basically as far as you can curl for that muscle. And so that is going to be denoted in this graph right here. And so what we're finding though, what this graph all is telling us is that there is this relationship between length and tension, where the optimal tension that we have is at rest, and then if you extend it or contract it too far, then we'll have a decrease in tension for that muscle.